Hello everyone. In today's class we will discuss the images found by a spherical mirror, and then we will discuss the mirror formula and its derivation. So let us start. You already know the basic things about spherical mirrors. There are the two spherical mirrors. One is concave spherical mirror, other one is the convex spherical mirror. You already know about their principal axis, their poles, aperture, center of curvature, radius of curvature, the focus, all these things. So now we can take the images found by the first mirror, which is, for example, it is the concave mirror. So image found by the concave mirror, where the image will be formed and what size of the image will be formed, and what kind of the image will be found, it will depend upon where the object is placed in front of the reflecting surface of the concave mirror, at what distance the object is placed, because with the distance, the size, the position, as well as the nature of the image found by a concave mirror changes. So here let us take the very first case. So very first thing is to draw a correct ray diagram. So for drawing a correct ray diagram, we are taking this MN to be a concave mirror. Outer surface is polished and inside surface is reflecting. So we have to place the object always in front of the reflecting surface over the principal axis. So the very first case we take is that the object is lying at infinite distance. So if object lies at very far off point, so that the light rays coming from that object are more or less nearly parallel to the principal axis of this mirror. So all the light rays which are coming from this object placed at infinite distance or very far off distance, they will come parallel to the principal axis or they will come parallel to each other. So all these light rays, after getting reflected from this concave mirror, we already know that the light rays, whenever they get reflected from a plane surface or from a spherical surface or any kind of surface, they always follow the laws of reflection. So they follow the laws of reflection, and all the light rays which are coming from an object at infinite distance, coming parallel to each other or parallel to the principal axis, after reflection from the mirror, they pass through the same common point which is lying on the principal axis. And this common point, it is nothing but the focus. So the point where the reflected light rays meet, they give the formation of the image of the distant object. So where these 2 points, two light rays, reflected light rays meet, we have to draw a perpendicular from that point on the principal axis, and length of that perpendicular will be the size of the image, right? And the point where the perpendicular is formed, it is the location of the image in front of the mirror. So here in this particular case, whenever object is lying at infinite distance, the image, or we can say reflected light rays, converge or meet or intersect at the focus, which is a point on the principal axis. So that means the length of the perpendicular will be 0. So that means there will be no need to draw the perpendicular as such, and we will see a very small spot of that distant object. If this distant object at infinity, it is a some light source, for example some light bulb or just like that, we will see a very small spot at the focus of the light, or we can say this object. So that means whenever object is at infinite distance, the image, the very first thing to tell is the location of the image. So the image is formed at the focus. The second thing is that whether the image is magnified, it is enlarged, or it is diminished, or it is of the same size. So we see that whatever the size of the object, whenever it is at infinity, its image is formed in a very small, we can say, dimension. So it will be just a spot if this object is at infinity, right? So we see that the size, second thing is about the image is that it will be of highly diminished size. So the image will be highly diminished. It will be of very small size, or we can say point size. Third thing, we have to tell that whether the image is real or virtual. So it is very simple to decide whether the image is real or virtual from the mirror, that whenever the image is formed on the same side of the mirror of the towards the reflecting surface, right, the image will be a real image, right? Or in other way, we can see that this image can be taken on a screen. If we place a small screen here, we will see a bright spot of that image of this object at infinity at focus f. So that means this image can be focused or taken on a screen. In that case also, we call that the image to be real. So it will be a real image of a highly diminished size and lying at the focus. So this is the first case. In the similar way, we can decide the location, the size and the nature of the image formed in all other cases. So second case is that now object is lying at some finite distance but still beyond C. Object is not at infinity now, it is at some finite distance which can be measured, still beyond C. So in order to derive the, or we can say in order to draw the ray diagram for the image formation, we need to draw only two light rays coming from the topmost point of the object AB. So this arrow, we are taking this to be object AB. So the topmost point is A. So we have to draw only two light rays. We are drawing the two light rays which are of specific kind, which we know where they will pass through after reflection from the mirror. So one light ray parallel to the principal axis, it always, after reflection from the mirror, it always pass through the focus. So here it will be the focus. And another light ray you can draw at the through the focus. It will always, after reflection, will go parallel to the principal axis. Third light ray, it can be drawn at the pole so that the light ray get reflected by following laws of reflection, making the same angle as the angle of incidence. And fourth light ray can be drawn through the center of curvature, which will just retrace its own path. It will get reflected back along its own path, because in that case the light ray will be incident on the mirror at right angle to the surface of the mirror, right? So here we need to draw only two light rays out of all these four. So just like here, from the topmost point of this object AB, which is lying beyond C at some finite distance, two light rays are drawn, one parallel to the principal axis. After reflection from the mirror, it goes through the focus. So this is the focus will be on the principal axis at some location. On the other side, a light ray through the center of curvature, it will just retrace its own path, means it will just get reflected back along its own path due to the kind of reflection taking place. So after reflection, these two reflected light rays coming from the same point are meeting at this point. We are giving it name A dash. So it is written AB, you can take it to be A dash. So this A dash is the image of point A. Similarly, you can draw all similar two light rays, one parallel to the principal axis, other one through the center of curvature, from every point on this object AB, so that its image will be formed over this perpendicular from A dash on the principal axis, right? So rather than drawing the light rays from each and every point on this object, because it will make the diagram to be very crowded, however you can practice it for your understanding. So we draw only one point, the light rays from one point, we get the image of that point. It is the point A, so its image can be represented as A dash. Here it is not written dash, you can take it to be A dash. We draw the perpendicular from this point on the principal axis, so the perpendicular is A dash B dash, here it is B dash, right? So this A dash B dash is the image of this object AB. So this is how the second case takes place. In the second case, the object is lying beyond C at some finite distance, and the image, the very first thing to tell is that where the image is formed in this case. In this case, the image is formed between C and F. It is C here and it is F here, right? So whenever object lies at some finite distance but still beyond C, its image will always be formed between C and F, the center of curvature and the focus of the concave mirror. Second thing to tell about it is that whether the image is enlarged or it is diminished. So we see that in this case the size of the image is smaller than the size of the object. So we can see say that the size of the image it will be smaller. So it will be a diminished image. Third thing, the image is inverted, right? This is the object is shown above the principal axis and image is shown below the principal axis. So that means the image formed is inverted, right? And the fourth thing to tell about this image is whether the image is real or it is virtual, because again the image is formed on the same side of the reflecting surface of the mirror, so which this image can be taken on a screen and hence it is a real image. Let us take the third case. In the third case, now the object is placed at C, right? So whenever object is placed at C, we again draw the two light rays from the topmost point, which after reflection from the mirror at point here, so that the image is also formed at C. So whenever object lies at C, means center of curvature of the concave mirror, the image will also be formed at center of curvature. This is the first thing to note here. And size will be of the image, it will be of similar size of the object. Third thing, it will be inverted image, because the object is in upward direction from the principal axis and the image is in downward direction. And the last thing is whether the image is real or virtual. We can see that this image can be taken on a screen, and other way to understand it that the image is again formed on the same side of the reflecting surface, so image is real. Next case is that whenever object is brought even closer and it is placed anywhere between C and F, just like this. So this is C here and this is F here. So whenever object lies anywhere between C and F, its image it is formed again from the topmost point of the object. We are drawing two light rays, right? So which after reflection meet at point A. This is to be taken as A dash. So A dash is the image of point A. So from here we draw the perpendicular again, so we get the image A dash B dash of the object A B. So anyway, any time whenever the object lies between C and F, the center of curvature and focus of the concave mirror, its image will always be formed beyond C, right? The first thing to understand here is the location. So image will be formed at some finite distance beyond C, right? And it will be of larger size than the object. It will be inverted image and it will be the real image. And whenever object is brought even closer than the C and F, okay, means the object is now placed at F. So whenever object is placed at F, we see that the image in this case, in order to find out the image in this case, whenever object is at F, means focus of the concave mirror, we draw the same two light rays, one parallel to the principal axis which passes through the focus itself, and other one through the center of curvature which get reflected back along its own direction. So we see that in this case the reflected light rays meets nowhere, right? Or in other way we can say that these light rays meet at infinity. So in that case we can say that the image is formed at infinity. So this is the very first thing to understand here. Anytime whenever object is at focus, its image will be formed at infinity. And it will be inverted image. It will be of very large size in comparison to the object and highly enlarged, you can call it, and it will be the real image, because if you place a screen, and because the image is formed on the same side of the reflecting surface of the mirror, right? And when the object is brought even closer than the focus, its image will be formed. We draw the two light rays in the very similar manner. We see that the reflected light rays does not meet anywhere on the, or we can say the reflected light rays never meet not at even at infinity on the same side of the mirror. So we extend these light rays in behind the mirror, which appear to be meeting behind the mirror at point this. So this will be the position, or we can say image of this point A. So it is A dash, we can write it to be A dash. So in this case we see that perpendicular drawn from this, it gives the image of this object AB. So image, it is formed now in this case behind the mirror, right? Behind the mirror, it appears to be formed. It is not formed, but it appears to be formed behind the mirror. So in this case we can say that anytime whenever object is closer than the focus, so focus will be somewhat here, so object is even closer than the focus, means the object lies between F and P. P is the pole of the mirror and F is the focus, right? So whenever object lies between F and P, its image will be formed behind the mirror, right? So this is the first thing, location of the image will be behind the mirror, and it will be of erect nature. It will be of erect nature because image is formed on the same side of the principal axis as the object, and size of the image will be enlarged, right? And other thing to note down here is that it will be the virtual image. Why it will be virtual image? Because it is not on the reflecting surface, on the side of reflecting surface, it is behind the mirror, it is towards the shaded, or we can say polished surface. So if we place a screen here, we will not see anything. So this image just appears, but it is not existing there actually. Now comes a convex mirror. So whenever object is placed on the in front of the reflecting surface of a convex mirror, we draw the two light rays similarly from the topmost point, and we get the image again behind the mirror, right, away from the reflecting surface. So in this case also image is formed behind the mirror, which is called as virtual image, just as in this case this is the virtual image. Okay, so it will be of somewhat smaller size than the size of the object. It will be the erect image. So this is about the image formation by the spherical mirrors, the concave mirror and the convex mirror. Now we move to the next important topic of derivation of the mirror formula. So very first thing to understand is that mirror formula is the formula or relationship between the object distance, image distance and the focal length of the mirror, right? So this formula will hold true for concave mirror as well as for the convex mirror. The mirror formula will hold true for the real image as well as for the virtual image, whatever the case is there. So this will be the formula which will work out for all kind of situation in case of reflection. So in order to begin with the derivation of this mirror formula, we start for example with a concave mirror. So we are taking a concave mirror MN. The outer surface is polished, so inner surface is reflecting. So we are placing an object beyond C or anywhere for which the image formed is real, for example. However, the derivation will be same for the formula will hold for the virtual image also. So we take this particular situation, for example. So object is placed beyond C. It is given name A, B. So we are drawing the two light rays from the topmost point. Here 3 light rays are shown. I suggest you to draw only 2 light rays so that it avoids the crowd of light rays here as well as it reduces the confusion. Okay, so we draw only 2 light rays from the topmost point in order to find out the image of this object found by this concave mirror. One light ray parallel to the principal axis, other one you can draw through the center of curvature or right at the pole. So after reflection, these light rays will meet at point A dash, which will be the image of this point A of the object. From here we draw the perpendicular on the principal axis, so it will be A dash, B dash. So this is the image of object A, B. From this point where this light ray meets the principal axis, this light ray which is parallel to the principal axis meets the mirror at point M, we draw a perpendicular line on the principal axis MS, right? So for the sake of convenience or in practical situation, we take the mirror to be of small aperture, small diameter. We take the mirror to be of small diameter. The mirror is so small in diameter so that point S, this point S of the perpendicular from point M, this point S lies very close to point P, the pole of the mirror. So whatever distance is to be measured from S, we take the distance to be from P. So this thing you have to assume. So this is the object AB, its distance is represented as U, and this is image A dash B dash, its distance is represented as V, and the distance of focus from the pole of the mirror, it is taken as F. All the distances are taken from the pole of the mirror. This is according to the sign convention, first sign convention. Okay, now to begin with, we consider two triangles, A dash B dash F and F M S. These two triangles, again A dash B dash F and A M S. These two triangles are similar triangles, right? Because their corresponding angles are equal. So because the two triangles are similar, so the ratio of their corresponding sides will be same, or we can say equal. So this is so it will be A dash B dash. So this side, the corresponding side is, for this side in this triangle, the corresponding side of the other triangle is MS, which can be written nearly MP because S lies very close to P. So the ratio of A dash B dash to the MS means MP. It will be equal to ratio of B dash F to the FS or FP. So in this light, I can write this, we can say ratio of the corresponding sides. So the two triangles are A dash B dash F and MPF. So we are not writing here MSF because S lies very close to P. So we just take S to be P. So that is why we are writing it MPF. So the ratio of their corresponding sides is same. Here A dash B dash A dash divided by PM, this is equal to B dash F upon FP, right? So here PM, it is nearly this PM, it is nothing but AB, it is equal to AB. So that's why in place of PM we are writing AB. So here in place of PM we are writing AB or BA. We give this equation as equation number 1. Similarly, we take another set of two triangles. It is ABP. It is a right angle triangle, and A dash B dash P. This is the another right angle triangle. Here also these two triangles are similar because at least two angles should be same for the triangles to be similar. So these two triangles are again similar, so the ratio of their corresponding side will also be equal. So the corresponding ratio is given by this. It is B dash A dash upon AB or BA. It is B dash A dash upon AB or BA. This will be equal to B dash P divided by BP. So this will be equation number 2. So if we compare these two equations, we see that the two triangles on the left hand side have the same value. So it means their right hand side will also be equal. So on comparing equation number 1 and 2, we see that on the one side we have B dash F upon FP, and on the other side we have B dash P upon BP, right? Here B dash F, this value can be written as B dash P minus FP. So B dash F, so we are just writing something for it. So B dash F, so this is B dash F. So in place of B dash F, what we are writing? We are writing B dash P minus FP. So the remaining distance will be b dash f. Okay, so that's why we are writing it b dash p minus fp, and in the denominator it is the same fp. On the right hand side it is also same b dash p upon bp, because all the distances according to sign convention are to be measured from the pole of the mirror. So this is the final result we get here. So the derivation is not complicated anyway. We take two sets of triangles, and the two sets of triangles are similar, so the ratio of their corresponding sides will be equal, and from there we see that both these two equations represent the same quantity on their left hand side. So that means the quantity on the right hand side will also be same. So we are comparing here and we are just changing b dash f to this. So this is the equation we get. Now the only thing is left is substituting the values. For substituting the values, we have to follow the sign convention, which are three, according to which very first sign convention is that all the distances are to be measured from the pole of the mirror. So if we are measuring the distance, for example, object distance of the object, or distance of the image, or radius of curvature, or the focus, focal length, right? So we have to place the zero of the scale on the pole. So that is what it means. The second sign convention is that along the direction of incident ray, in which the incident ray travels. So this is the direction in this particular case. This is the direction in which the incident ray travels. All the distances along this direction being measured along this direction will be taken as positive, and if the distances are being measured opposite to the incident ray, all the distances are to be taken as negative and substituted with the negative sign with them. So from here, let us take this case, b dash p. So b dash p. So it is b dash p. It is nothing but the distance of the image from the pole. So we have to measure it from the pole. Rather than writing b dash p, it will become easy to remember and also comprehend to write it as p b dash, because all the distances are to be measured from the pole. So p b dash, this is 0 is to be placed here, and distance is being measured in this direction which is opposite to the incident ray, so this will be negative. So it will be substituted as minus v. Rather than v, we substitute its value in with a minus sign. Similarly, bp, or it is better to write it as pb, which again will be negative. Distance of object will always be negative, right, from the pole of the mirror. So here in this particular case, the image distance is also negative, and if it is pf or fp, it will be substituted again negative, because the distance will be measured opposite to the incident ray. So all these distances are to be taken as negative and substituted in the formula here. So b dash p, it will be negative minus v, fp, it will be minus f, and bp, it will be minus u. So on substituting, we get this. We are substituting these values from here to here in this equation, and therefore on getting, we get this value. On all calculation simplification, we get this formula: 1 upon u plus 1 upon v, it is equal to 1 upon f. This formula, it is nothing but the mirror formula, right? This formula will be true for the convex mirror also, or for the real as well as for the virtual image, as the case may be. So this formula will hold true for all kinds of the images formed, or for all kinds of the mirrors which cause the reflection for the image formation. So this is about this formula. And if in a numerical question, application question, the values of u, v, and or we can say f is given, and we have to calculate the third value. For example, out of these three, if 2 is given and third is to be calculated, we make use of this formula, and we substitute the values of u, v, or f according to the sign convention. So we have to identify the situation in the given in the numerical, that what kind of image is formed. For that, we have to understand where the object is placed and where the image is placed, formed. Only then we can decide about the signs of u, v and f. However, in case of concave mirror, the value of f is always taken as negative, and value of f in case of convex mirror, it is always taken as positive. Whatever the situation is, it may be real image or it may be virtual image. And also the value of u, it is always negative. Right? It is the value of v which is to be decided depending upon whether the image is real or virtual, as the case is. So this is how we solve such type of questions. That's all about this topic. Thank you.